So far, all of the computations we've been doing are based upon current dollar prices. So we've been computing nominal returns, that is, returns based in current dollars. From an economic point of view, when we think about our investment, we often want to take into account the effects of inflation. We would like to know what is the real return on our investment. So what is the return accounting for the growth in the general level of prices? So when we adjust for inflation, we're computing what's called a real rate of return instead of a nominal rate of return. So how do you calculate a real rate of return? Well, the general way is to take our nominal price and deflate it by some measure of the price level. And the common measure of the price level might be the consumer price index, which is an aggregated index of the typical basket of goods that a household purchases. And so the Bureau of Labor Statistics publishes the consumer price index every month. You can go to the Fed database at the St. Louis Fed the St. Louis Fed website, and then download this data from the Bureau of Labor Statistics, and then you can get your CPI data. So you take your prices, and then you divide by the CPI to take your nominal price into an inflation-adjusted price. And then once you have your deflated prices, you can calculate the real return by calculating the percentage change in the deflated price. So to illustrate, so what is the real price at time t? It would be the nominal price divided by the CPI at time t. Then the real rate of return would be the percentage change in the real price. So that's computed this way. Now, we can make use of the fact that the real price is the nominal price divided by the CPI, so we can look at this real percentage change in price computed this way. And notice that we have everything divided by the CPI. So we can do some algebraic manipulation to rewrite this as PT divided by PT minus 1 times the CPI times T minus 1 divided by the CPI at time T, and then subtract off 1. Now, inflation generally is defined as the percentage change in the general price index. So pi t is what commonly economists use as the symbol for the growth rate of prices. That's the inflation rate. That would be the percentage change in the CPI index. So given this definition of inflation, we can rewrite the real return as, in fact, 1 plus the nominal rate of return divided by 1 plus the inflation rate minus 1. Okay? So our real rate of return is related to nominal and inflation, but it's not quite as simple. It's not the nominal rate of return minus the inflation rate, right? We have this relationship here. So if we're doing a numerical example, let's, for simplicity, say the consumer price index was 1 at time t minus 1 and was 1.01 at time t. So we see that the consumer price index increases by 1% over the month. So then our real price at time t minus 1 would be 85 divided by 1. Our real price at time t would be 90 divided by 1.01. And so we see the effective inflation has reduced the nominal price. And then our real rate of return over the month is the percentage change in the real price. It would be 4.83%. So before inflation, we had a nominal return of 5.8%. With 1% inflation, our return has been decreased by approximately 1%. So going back, our nominal rate of return was a percentage change in the nominal price was 5.88%. Our inflation rate was 1%. So our real rate of return was 1 plus the nominal rate of return divided by 1 plus the inflation rate minus 1. And that's exactly what we got as the percentage change in the real price. Now note that the real rate of return, which is 4.83%, is almost the nominal rate of interest minus the inflation rate. So we have a 4.88% versus 4.83%. So from a practical point of view, a rule of thumb, if the inflation rate is not too big and your rate of return is not too big, is the real rate of return is approximately the nominal rate minus the inflation rate.